Hello everyone, Michael with you here once again, and welcome to episode 5 of the Java VTM. That's right, after weeks and weeks of waiting, we're finally back. Kind of sorry about that, but what can I say? I've been pretty busy, and that's my excuse. Not to worry, let's get straight into it. In this video, we're going to be looking at how we can do repetitive tasks in Java. Often when we're writing programs, we need to do the same piece of code a number of times, and there are different ways that we can do this in Java. They're called loops. So this video is sort of going to not be too tricky. A lot of what we do in this video is things that we've learned in the last video when we looked at Boolean expressions. Boolean expressions are also really important when we're looking at loops. So, what exactly are we doing? Well, I jump over to my upgraded Paint package. This Paint.net is just an open source painting application written in C#, I think. I'm just using it because it draws slightly smoother lines than what Paint does, so hopefully my crappy drawing is a little bit easier to read. So anyway, in the first two videos we had some really simple programs that was just linear execution. Things like that. And then when we looked at if statements and switch statements, we had some execution. Should have played with this beforehand. And then we had a decision, which was a Boolean expression. And if this was true, we did some piece of code, and if it was false, we did a different section of code. And then they might have joined up a bit later on. Now, a loop looks kind of similar to this, but it's a bit different. The basic structure is we have our code just like before, and then we have a decision. Now, if this is true, we execute a block of code, and then when we're done with that block of code, we come back to the expression again. And Java reevaluates this expression. Now, if it's still true, then we execute the code again, and this continues until it's false, in which case we come out and we do something else. So that's the basic idea of loops, and there are three main ways that we can do this in Java. And we're going to look at all three, and then we're going to write a kind of interesting program. We're going to write 2 Java files today. The first one is just going to be testing out how loops work and the 3 different types of loops and how we can do them. The second Java file is going to be a simple little program that generates the numbers in the Fibonacci sequence. Now, if you don't know what that is, basically a long time ago, this guy called Fibonacci came up with this series of numbers, and it's all really special. If you're unfamiliar, type in Fibonacci into Google, click on the first one, and this is what we get. Basically, Fibonacci numbers are numbers where the next lot in the series is obtained by adding the previous 2 together. Now, what did I mean by that? Well, we've got these first 2 numbers, 0 and 1. They are special cases that sort of start the ball rolling. The next number, which will be 1, is obtained by adding 0 and 1 together. Then to get the next number, we add 1 and 1 together. We get 2. Then add 1 and 2 together, 3, 2 and 3, 5, etc. This goes on forever. So that's what Fibonacci numbers are, and we're going to use loops as a really kind of interesting, I guess, way to generate something that's a bit interesting. So anyway, this first program, loop test.java, test the 3 types of looping. Now, just like before, we'll have a public class loop test, and like all our programs, a main method, public static void main string args. Now, don't worry, this is coming up so soon. This is basically says string array args. We're looking at arrays in the very next video, so this will become kind of, you'll know what this is, and we'll be able to use that, and it's all awesome. But for now, again, we'll just leave it. Don't worry too much. So anyway, the first type of loop we're going to look at is the while loop. And the while loop it looks kind of similar to what an if statement looks like, but it works a bit differently. Basically, we start off with the keyword while. Then in here we have a Boolean expression, so for now let's just put true. Then we have a block of code. And we're going to put a print line statement. Okay, so what happens is Java gets to this line of code, it has a look, and it evaluates this expression. If this is true, then it executes this block of code. When we get to the end of this block, it comes back up here and re-evaluates the expression. If it's still true, then we execute this code again, otherwise we break off and continue our program. So why don't we just save and compile this? Oh, I'm in the wrong directory. Sorry, ls Unix command, what can you do? Anyway, we'll just compile this. javac loop test.java. Now, what do we have here? Oh my god, what is happening? Java is constantly printing out print lines saying that my Java VTM rocks. And if you have a look at this, we're using a fair bit of the CPU. Now, this is a dual core processor, so it's using quite a bit of our system to do this. Basically, if we come over to our code, while true. Now, are we all in agreement that true will never equal false? Well, of course it won't. That doesn't make sense. So what we have here is an infinite loop. Because this is always true, Java will never break out of this loop, and so it's constantly doing print line statements. That's something to look out for. When we're programming, it's very easy to accidentally come up with infinite loops, and they can be a bit tricky to find and debug. So keep that in mind when I'm writing programs. So anyway, this is still printing out. What do? The only way to stop this is by killing our program by pressing Control-C. Okay? And then we're back to the start. Another thing, what can we do? Well, in here, it doesn't just have to be while true. It can be any Boolean expression that you can come up with. Same as in the last video when we looked at if statements. So often we want to do a piece of code a number of times. So let's come up with we'll start off with an int variable, number equals 0. And let's say we want to print this out 10 times. We can go while, not while, we've already got while, number is less than 10, print this out. Now the important thing here to remember is that because this is being evaluated every time we end this block, if number doesn't change, then we still have an infinite loop. So let's just test that. Again, an infinite loop. This is even more common. When you're using a variable to count how many times we've iterated through something and we're using that as part of our condition, make sure you update the value of this variable. Otherwise, you're going to run into infinite loops again. So, in this case, number plus plus. Just increment number. Print it out 10 times and we're all fantastic. So, because each time we're incrementing that, so the first time it's equals 0, then 1, then 2, then 3, and so on, until we get to 9, it goes then, is 10 less than 10? No, it's not, so we break out and we end up down here. There's nothing left in our code, so our program finishes. That is the basic structure of a while loop. It doesn't really get any more complicated than that. Of course, we can do some interesting Boolean expressions in here to do some crazy output, but that's the basic idea of a while loop. So for now, let's just comment this out. Okay, the next type of loop we're going to be looking at is called the for loop. And it kind of works in the same way as what this while loop does, but the syntax is quite different. The first thing we have is the keyword for, and then parentheses, and then a block of code. But what's different is what goes in these parentheses. It's divided up into 3 parts. The first part, we usually have a declaration. In this case, we'll do exactly the same thing as what we have here, okay? Int, and we'll just use the variable called I equals 0. Semicolon. Semicolon's important. The second part inside the parentheses is our Boolean expression. For example, number less than 10. this is what gets evaluated each time we iterate through the loop. So for now we'll have I less than 10, semicolon, and then finally, go away. Finally, at the end of this, we have the operation. In this case, we'll have I++. And then I'll put the same print line statement here. So what happens? Well, first time Java gets to this, it declares a variable called I and initializes it to 0. Then it evaluates this expression, is I less than 10? Yes, it is. So we print out this code, and then we get to the end of the block, so we come back up here. Now this operation gets done now, so now I is equal to 1, because we've incremented I. Is 1 less than 10? Yes, it is. So it continues. Basically, this functionality is exactly the same as what this was. The for loop is just a kind of more elegant way of writing this sort of loop. There are times when while loops are better, sometimes for loops are better. But generally, when you know how many times you are going to iterate through something, how many times you're going to loop, then for loops are a bit more elegant. They force you to put this operation in when we start the for loop, so we never forget. We don't very often see infinite loops like this in for loops. It's just, I kind of like them. But anyway, let's test this to make sure it works. Compiles, fine. And we get the same output. So that is fantastic. That is what a for loop looks like. And really, there's not all that much to it than that. Of course, you can do any sort of operation here. You don't have to do I++. We could do I plus 2, for example. That means it'll only print out 5 times. Oh. Now, we can't do I plus 2. That's not a statement. If we're going to do something like that, before we were using the increment shortcut, I++, if we want to do something different, we probably have to go I plus equals 2 or I equals I plus 2. Something like that. Now we compile and it runs and it prints out 5 times. So that's fantastic. That's pretty much the for loop covered for now. We'll comment this out. Finally, the third type of loop is similar to the while loop but slightly different in how it works, and it's called the do while loop. The main difference is if we come back over to Paint. Okay, the while loop functions exactly as how that diagram I drew before does. We've got some code, and then we have a decision, and then if it's true, I'm going to get this out of the way. If it's true, we execute some code and then come back to the decision. If it's false, then we break out and we do something else. That's the idea of a while loop, and for loop really works in the same way as this. The do while loop is a little bit different. There we go. The do while loop, we've got our code executing normally, and then we get to this do block. We get to a block of code, so I'll just put a dot here to recognize that. We have a block of code. And then we have our expression. If this is true, then we jump back up to the start of this block. Otherwise, we break out. Now, the difference, hopefully you can see that in a while loop, the expression is evaluated first. And only if this is true does our block of code get executed. In a do while loop, this block of code will be executed at least once because it gets executed before we even get to the decision. Okay? If this is true, then we jump back up and execute again. If it's false, then we break out. But the difference is we've already executed this block of code at least once. Okay? That's the difference between a while loop and a do while loop. So how do we do a do while loop in Java? It's very simple. I'll just do it here. We have the keyword do, and then we have our block of code, and then we have while, and our expression. Semicolon. That's what a do while loop looks like. Now, how can we demonstrate the difference? Well, this is actually my third time trying to record this VTM. I've had a bit of trouble with my screen capture software, but that doesn't matter. what we'll have is a print line. Actually, I'll leave this commented out and I'll just type it again. We could use this later. What I was going to do basically was have while false. And then we'll have a print line statement saying which loop this was printed from. Okay. Now the problem is that this won't compile. Why is that? Well, if we have a look at the error we get, unreachable statement. Basically, because this is while false, the Java compiler knows that this will never be true. In other words, this statement will never, ever, ever, ever be executed. The compiler can tell this. And so it'll give you an error saying that, hey, you've got some code that's never going to be executed. Maybe you should check to make sure you've done it properly. So that kind of ruins that idea. But what we can do is trick it by, if we get an int and we declare an int called number and we get it from the keyboard using our keyboard class from the last video. And then we can do while number is less than 0. Now, we got the same expression in both of these loops. If we enter a number that's greater than 0, such as 5, which is what we'll do, 5 is not less than 0, so this will evaluate to false. But the Java compiler doesn't know that because we don't know what number is going to equal until runtime. Okay? So we'll just save that and compile that. Compile's fine now. Okay. We've got a blinking cursor. What we really should have done is put in a print line statement saying enter a number. But that's okay. We know what we're expecting. So let's enter 5. The do while loop executed fine. Executed once. But the while loop didn't execute at all. That's because the do block will always be executed at least once, and then we evaluate this expression to see if we repeat it. Whereas the while loop, we evaluate the expression first to see if we even enter this block. So that's the fundamental difference between a do while loop and a while loop. Okay? With that, that is pretty much it. All I want to do for this class. Now let's create a new file and we'll get onto this Fibonacci number sequence thing generator. So, change the language to Java. Fibonacci.java calculates the Fibonacci numbers. Okay. Public class Fibonacci. Public static void main string array args. Okay, so what are we going to do in this video? Just in this program. The first thing we're going to do is get a number from the user. And this number is going to say how many Fibonacci numbers we're going to generate. So we'll have an int variable called iterations. And we're going to set this number from the keyboard. So first thing, system.out.print. I'm not going to have a print line here, I'm just going to have a print. And that's because we want it to look like this, where the blinking cursor is right after the line. If we had a print line statement, the cursor would be down here. It's just something nicer. So print, enter the number of iterations. Just like that. Now we set iterations equals keyboard.read int. Okay, what's next? Well, first thing, let's do a bit of error checking. Let's make sure that they don't enter a number that's less than 0. If they enter a number that's 0 or less, then it really doesn't make sense to do any code. So, the first thing, if iterations is greater than 0, this is where this block of code is where our main code is going to go. But we'll have an else here saying system.out.print, pirate, number must be greater than 0. Okay, that's all we're going to do. Now, in here, what are we going to do? What are we going to do? Well, let's have a look at the Fibonacci sequence. These first two numbers are kind of like special cases to get the ball rolling. We can't get this first one by going -1 plus 0. It doesn't work. So we have to do these cases specially. We can't really put them in the loop. It doesn't really work very well. So the first thing, if the iterations is greater than or equal to 1, we're going to print out 0. Because if there's one iteration, that means we only print out the first number, so it's 0. And then we're going to have another if, saying if it's greater than or equal to 2, if iterations is greater than or equal to 2, we're going to print out 1. And that'll get our first two special cases out the way. So, if iterations is greater than or equal to 1, system.out.println, print out 0. If iterations is greater than or equal to 2, system.out.println 1, because that's the next number. So now we've got those two special cases out the way. How do we go about working out the rest of the numbers? Well, it's really easy. 2 is obtained from adding 1 and 1 together. 8 is obtained from adding 3 and 5 together. Basically, all we need to do is keep track of the previous two numbers and then add them together to get the next number. Okay? So that's going to involve two variables. So we'll go int previous 1 equals 0, int previous 2 equals 1. Now, why did I use 0 and 1 for these initial values? It's simple. That's what the first two numbers are. So there we go. Now, what are we going to do? Let's use a while loop for this. Yeah, we'll use a while loop. We'll go back and do it with a for loop just to prove it can be done. So, we're using a while loop, and we need to keep track of how many times we've iterated through it. So, we need another int variable, int. And we'll just call this I, because I is sort of like the general purpose name that we give to things for like iterating through a set of objects or keeping track of how many times we've looped. It's just something easy. Usually when we create variables we use meaningful names. I is just sort of like a standard thing, so don't worry about that too much. Int I. Now what do we initialize this to? Well, we're going to set it to 2. Why 2? Well, we would kind of think we'd set it to 0, but you have to remember that we've already included 2 iterations here, and that's important. So int I equals 2 to start with. Now, while our condition is going to be simply while I is less than iterations, what do we do? Well, let's have a variable in here, int current, and that's going to be equal to the previous 2 added together. So int current is going to equal previous 1 plus previous 2. And then we're going to print this out. Okay, what are we going to do next? Well, we need to reset these previous numbers. Once we've got this, once we're up to the next one, the value that's in previous 2 is going to be moved into previous 1. And then the current value is going to be moved into previous 2. Okay, I hope that makes sense. It shouldn't be, it's really obvious when you see it. So for now, previous 1 equals previous 2. Previous 2 equals current. And that gets us ready to do the next iteration. Finally, because we've got a while loop, remember to increment this I plus plus, and that's the end of our while loop. And with that, that should be enough to get this working. So we'll just save this, Java, Fibonacci.java. Okay, we're ready to go. Now, because we're using the keyboard class as well here, it's kind of important. Actually, we could have got an error over here because we use keyboard. I'm in a directory where all my Java VTM stuff is already compiled, all the previous gear. So if we go dir star.class, you can see that keyboard has already been compiled. If you haven't got keyboard class compiled, you've only got the Java file, make sure you go jarvac star.java to compile all the Java files in your directory. Okay? That's easy. So now Java, I'll just clear the screen. Java Fibonacci. Enter the number of iterations. Let's enter 5. 0, 1, 1, 2, 3. It's printed out 5 numbers at 0, 1, 1, 2, 3. And it printed out the correct numbers. So, awesome. We've got a working Fibonacci number generator. What happens if we do some massive number? 100 iterations. Wow, what happened here? We scroll up a bit. We can see that because we're starting to add big numbers together, Fibonacci numbers get really big really quickly. And then we get to here, and all of a sudden it's a negative number. What's happened, if you remember in the second video when we printed out integer.maxValue to show the biggest number that an int variable could hold, basically what's happened is when we've added these two numbers together, we've gone over what an integer can hold. And what that means is that if you're looking at binary numbers where everything is stored as ones and zeros, like, oh, not a 4 and not a 5, just ones and zeros, what happens when it gets to the biggest number that it can store, i.e. a lot of ones, the next value that's going to get, well, because it loops back over, it's going to be a lot of zeros. And this gives us back our negative number. So that's what's happening. We're getting number wraparound. We can get around this a little bit by changing all our ints to longs. Because I'm lazy, I'll just copy and paste this. So if we compile this and run it again, and enter 100 iterations, you can see that we get a lot bigger number before we get to this wraparound, because a long uses 64 bits, whereas an int only uses 32. So a long can store a much larger number. But anyway, that's our Fibonacci number sequence generator working awesomely. Just as a quick note to prove that we can do it, let's comment this out and do the entire thing again using a for loop. It's going to be very similar to this while loop, except we're using for loop syntax. So, keyword for, parentheses, we have a declaration, int I equals 2, semicolon. Our condition, while I is less than iterations, semicolon. And then what are we going to do? I++. And then the rest of the code is basically just copy and paste from here. Everything else is the same. And we can prove this works quickly by recompiling. We'll do 5, and it works again. So you can see that you can do the same thing using a for loop as you can with a while loop. The only difference is the syntax we use. While loops are really handy for certain things, and for loops work better for other things, but the point is they both work. With that pretty much wraps up all I want to say in this video. Hopefully it wasn't too much for you, because most of the hard work when dealing with loops is the Boolean expression, and we covered a fair bit of Boolean expressions in the last video, so this shouldn't have been too much. We looked at all 3 types of loops available in Java: the while loop, the do while loop, and the for loop. I talked about infinite loops and what to watch out for. Make sure you increment this. For loops are often very handy for certain things. You just have to be careful with them. So what else have we talked about? That covers pretty much everything I want to say. So that's going to wrap up this video. Thanks a lot.